Welcome to Math GPT. Today we'll learn how to find the volume of a solid generated by revolving a region bounded by y equals x and y equals square root of x about the line x equals 2 using the cylindrical shell method. Let's start by graphing our region. First, we'll draw our coordinate axes. Now let's plot y equals x in blue and y equals square root of x in red. These curves intersect at x equals 0 and x equals 1. The region we're revolving is bounded by these two curves from x equals 0 to x equals 1. We'll be revolving this region around the line x equals 2, which is this vertical line here. The cylindrical shell method works by taking a thin vertical strip of our region and revolving it around the axis. The radius of the resulting shell is the distance from our strip to the axis of rotation. The height of the shell is the difference between the upper and lower functions at that point. The volume formula for a cylindrical shell is 2 pi times the radius times the height times dx. In our case, that's 2 pi times the quantity 2 minus x times the quantity x minus square root of x, dx from 0 to 1. When we distribute, we get 2 pi times the quantity 2x minus 2 square root of x minus x squared plus x times square root of x. After integrating and evaluating from 0 to 1, we get our final volume. And there we have it. The volume of our solid is 4 pi over 15 cubic units.